Hi everyone, today I will talk about the homework 11. Let's look at the first question. The stochastic process xt is real WSS with autocorrelation Rxs tau and power spectral density Sxs omega show that. So problem A, Rxs tau is real and even. Problem B, Sxs omega is even and non-negative. Let's look at the question A first. Question A is Rxs tau is real and even. First, we prove that Rxx is real since xt is real. WSS, then of course Rxx tau is real. Second, Rxx tau equals to Ext plus tau xt is real, right? Since xt is real, WSS and Rx tau is equals to this, and we can get that it is real too. Rxx tau equals to Rxx tau t plus tau t Ext plus tau xt Ext plus tau Rxx t plus tau Rxx minus tau. Through this formula, we can get that Rxx tau equals to Rxx minus tau. So we can get that Rxx tau is even. Okay, let's look at the question B. Sxx omega is even and non-negative. First, we prove that Sxx omega is even. Sxx omega equals to integration Rxx omega e minus j omega tau equals to integration Rxx cosine omega tau d tau minus j integration Rxx tau sine omega tau d tau. And we know from the question A that Rxx tau is even function and sine omega tau is odd function. So the multiple of these two functions is the odd function. So from the negative infinite to positive infinite, we can get that this function is equals to 0. So we get that 0. Since it is cosine, the negative infinite to the 0 equals to 0 to the positive infinite. So it is equals to 2 plus 2 multiple the integration from 0 to the positive infinite Rxx omega cosine omega cosine omega tau d tau equals to rxx omega cosine minus omega tau d tau. It is equal to rxx minus tau, right? So sxx tau equals to sx minus tau, so sxx tau omega, or sxx omega is even. Next, we need to prove that sxx omega is non-negative. Let's discuss the following example. Xt through WSS process, we get H omega. H omega is a Laplace process. Through this process, we need to do the Laplace process and inverse Laplace process, and we get the Yt. We suppose that H omega is an ideal bandpass system. What is bandpass system? When H omega equals to 1, 0, 1. When H omega is 1, omega larger than omega 1 and smaller than omega 2. This is otherwise. Let's find E y t square. First, E y t square is larger or equal than 1, and it is equal to 1 over 2 integration H omega square sxx omega d omega 2 pi over 1. Oh, sorry. Since we know that omega 1 is only equals to 1 when omega is larger than omega 1 and smaller than omega 2, so omega 1, omega 2, sxx omega d omega, right? We see that the area of sxx omega in any interval is non-negative. So it is possible only if sxx omega larger and equal than 0 everywhere, right? So we get this. So we finish the proof. So we successfully prove that sxx omega is even and non-negative. That's all of the question 1. Thank you.